So I'm going to make some changes here. Because we're using x, I want to use y also because it's easier to graph. So I'm just going to change these equations by changing L into y. That's all I'm doing. So this is going to be 5 plus y, or sorry, x plus y is greater than or equal to 20, and 3.5x plus 5y is less than or equal to 80. Okay, so when you're solving for these equations, you want to make it so y is by itself, right? So the first equation I want to focus on is right here, is x plus y is greater than or equal to 20. So what should I do so that y is by itself?
Oh, you subtract y from both sides.
No.
It's close. What do we do?
Subtract x from both sides?
Right, we subtract x from both sides because the only thing that's with y right now is the x, so we want to move it to the other side. Okay, so you can see here that now we have it in this form. It's in its slope-intercept form, so it's a lot easier to graph, right? It's a lot easier to graph. The second equation we want to change is 3.5x plus 5y is less than 80. So what should we do first here? What should we do first here? Does anyone know what is our first step here? Joaquin? Right, we're going to subtract 3.5x from both sides. We get 5y is less than or equal to negative 3.5x plus 80. And then what is our next step? We're almost done. Joaquin? Right, we divide both sides by 5, and again, if anything is separated by a plus or a minus, we need to divide it by 5. We get y is greater than, I'm going to actually change this and multiply the top and bottom by 2 because we can't have a fraction. And then we get plus 16. So 3.5 divided by 5, the equivalent is negative 7 over 10. The reason I'm changing it is so that it doesn't have a fraction. You're not supposed to have fractions or decimals in fractions. You're not supposed to have decimals in fractions. Okay, so now that we've converted both of these equations or inequalities, now we can go ahead and graph them. Okay. So I'm going to make a very tall graph here. Okay, so I'm going to graph both of these inequalities now. So we have y is greater than or equal to negative x plus 20, and we have y is less than or equal to negative 7 over 10x plus 16. Okay, so the first step here is to graph the y-intercept. So I graph it at 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It looks like it was a little high. And the other one is at 16, so 19, 18, 17, 16. Okay, so I've graphed both of these inequalities. The first one I graphed, it went down one, right one, down one, right one. The other one was down 7, to the right 10. And then for the first graph, you shade above so it would be shading above right here. Actually, that doesn't seem right. Sure. We're shading above this line, right? And the other one we're shading below the line. So the area that they have in common is right here. The area they have in common is right here. 1, 2, 3, 4, 5. Okay, so one of the questions they might ask us is if Jonah buys 20 candles, or small candles, how many large candles can Jonah buy, right? 1, 2. So if you look at this, you can see here that at 20, there are 2 values that are for y that are in the shaded area, right? So the left-hand side is talking about number of large candles, and the bottom is talking about number of small candles. So what you would do is you would go to 20, and then you would go and see, okay, Jonah can actually buy 0, 1, and 2 large candles, and this statement will still be true, right? It fulfills the requirement that Jonah can't spend more than $80, and it fulfills the requirement that Jonah will buy at least 20 candles. So if they ask us, if Jonah buys 20 small candles, they might ask us, what is the maximum amount of large candles Jonah can buy? So in this case, what you would do is, again, you would go to 20 where the small candles are, and you would count, you would look at the shaded area, what of the y values are in the shaded area. Those are all possible solutions, okay? So again, if the question was this, if Jonah buys 20 small candles, what is the maximum amount of large candles Jonah can buy? And then if we look at our shaded area and the maximum is 2, right? The maximum integer or whole number is 2, then the answer would be 2 large candles. Okay. Does anyone have any questions about that? So if they asked us for the maximum, that means they're looking for the maximum y value in that shaded area, right? They're looking for the maximum y value of the shaded area. They could also ask us if he buys 2 large candles, what is the maximum amount of small candles Jonah can buy? So in that case, if they give us the y value, which is the large candles, then you would look here and you would see, okay, what is the maximum x value when Jonah buys 2? And you can see here that it's about 20, right? It's about 20 small candles. Okay. So what you're looking for is that your answer should be in the shaded area, and you want to use logic to determine what the maximum, the minimum values for what they're asking for. Does anyone have any questions about that? Does anyone have any questions about that?